Hello, and welcome to Log Periodic. Log Periodic provides a way to collect and visualize log messages, tracing data, performance statistics, and more from your systems. It works for both simple setups as well as dynamic cloud architectures. Let's see how it works. After we sign up for a Log Periodic account, we'll be presented with the dashboard screen. The dashboard screen lists your current environments and allows you to create new environments. Environments are containers or collections of log messages. Let's create an environment called Screencast. Now that we have the Screencast environment, we can enter into it to view the environment-specific data. Let's create an API key for this environment. API keys, similar to environments, have names. So let's call this one local testing. And click Create API Key. Now that we've created an API key, it appears here in our list of API keys. There are also temporary API keys, which are issued for website browsing. Right now, I don't have any. After we've created an API key, we can click on the API key to see more details about it. Here we can see that we have a sample config, which we can copy and paste into a config file later. In order to add log messages to your environment, you need to install the logp command. You can click on this link for details. The easiest way to install logp is by using your operating-specific packaging mechanism, such as apt-get or yum, but there are all various other alternatives, including compiling from source. In my case, I'll use the apt-get command. I already have the latest version. Let's go back and get the config file from the website and put it into a config file. You can either put it in etc/logp.conf where it takes effect for the whole system, or you can put it in the user's home directory as .logp.conf for it to just affect that user. I'll put it in .logp.conf. After the config is set up, try running logp ping. It will connect and tell you some information about your connection times. The next way to add log messages is simply the logp run command. Essentially, you can take any Unix command you would run on the command line and prefix it with logp run. In my case, let's just run a simple logp run sleep 10 command. This will sleep for 10 seconds. And while it's running, upload the statistics and the information about the run to Log Periodic. If we go back to our Screencast environment, we can open the Event Explorer. This shows information about the currently running events and gives a history of previous runs. Here's our sleep 10 command. We can see the user and the host, where it was run, the command itself, the exit status, when it started and how long it ran, and there's various other bits of information hidden behind here. Another interesting aspect is that all these displays in the Event Explorer are updated in real time. For example, if we run another sleep 10 command and go back to the website, we immediately see that it is registered here. Let's kill it. Observe that it immediately indicated the kill interrupt signal on the display. Another useful feature of Log Periodic is the timeline. If we select this timeline and drag it, we can add it to our display here. The timeline is a Gantt chart-like display of the different commands you ran. We see this red bar, which represents the current time, as well as the two different commands we ran. Hovering over them shows similar information to the event screen. The Log Periodic Event Explorer interface is a window-based interface that is highly customizable. For example, windows can be resized, repositioned, added as tabs, and saved and restored in different layout configurations. Going back to the timeline display, we see that these different events are colored differently. Green indicates a successful run of an event, And red indicates some kind of exception. In this case, an interrupt signal. Also, a non-zero exit code would appear red. When you hover over an event, you see multiple other options. When you click on a timeline for a particular event, it opens another display. This is the event-specific timeline, and in this case, it's not that interesting because the sleep command wasn't that interesting. Let's run something more complicated. Let's run a compile. If I go logp run make on this project, which is the logp command itself, go back to our events display, we see make is running here. Let's open the event timeline for make itself. We see that it's currently running, which is why it's grayed out. We also see standard I/O activity, which is printed. And we can also open the processes display to view the individual processes that are being spawned by make. You can also hover over each one of them to see more details. The color of these processes is arbitrarily chosen depending on the command that was run. For example, we see that the G++ command itself is dark brown, and CC1+ is a light blue, assembler is purple color, and so on. If any standard error was printed, you would also see it down here, and it would be red color. Now that the command is completed, we see that the event itself has turned green, and new subprocesses, and all the subprocesses have terminated. At this point, let's check out the resource usage of this command. We open a new window here. Of course, this can be rearranged as we choose. In this case, we see how much CPU time was used by the event, as well as how much memory, minor page faults, and other information. This information is taken from getRUsage, which is a very low overhead instrumentation of your commands. And essentially it's similar to running user bin time or your shell's time to view this information. Let's consider again the stdio, the standard input-output. The standard output of a process is captured and displayed, and as I said, the standard error would also be captured and shown in red. This view is the event timeline view is a good way to see when exactly in relation to the processes different output was printed. However, if you want to see a full display, you can click on the Event3 stdio window. This window is a display of the stdio itself, a full display, in which case you can copy paste if you're interested. You can also do some grepping if you want. You can filter also by stdout and stderr. In this case, there's no stderr, but I'll show an example of that in a second. Finally, you can copy and paste a command on your terminal. Copy and paste a command into your terminal to view the output on your terminal, in which case you can apply your own pipelines and various things as well. Another fun example of logp is running a shell. Let's run logp run bash and go back to the Event Explorer. I'll just clean up these windows a bit. Going back to our timeline, we see that bash is now running. It's, again, a gray color, indicating that it's still in progress. Let's open up the timeline specific for this event. Here we see essentially the same thing. Expanding processes, we see now all we've run so far is bash. I'll go back to the command and type echo hello. We see the standard out is printed here. Notice that no echo process was executed because it was the shell's built-in echo. We can type printf hello. Also the shell's built-in. How about Perl print hi? Now we see that we've actually spawned a Perl command. Similarly, we can say Perl die. Now we've seen an example of the standard error. This is a good way to monitor the commands that are actually run by a particular login shell. Sometimes might be useful for automated deployments like Chef and Fabric and so on, tracking what was actually done on a server. But there are many other use cases for this technology. When we exit the shell, the command has terminated. For a slightly more detailed timeline, I can show you another environment I have here. This environment is more populated, so you can get an idea of how it looks then. Thank you for watching this introduction to Log Periodic. In this video, we've only scratched the surface of what Log Periodic is capable of. Log Periodic is a very flexible and efficient real-time protocol with, we believe, lots of potential. Whether as a development and debugging tool, or a system for sysadmins to perform audits, incident investigations, and monitoring, or even as the missing interactive environment for serverless or function as a service systems, please consider Log Periodic.